Guys, and welcome to the video for the introduction to domain and range. So in this video, guys, I'm going to be talking about the domain and the range of a function. And you're learning this because it's essential to be able to describe the domain and the range of a function in Algebra 2. And so when we're done, you should be able to describe the domain and range of a function using terms like integers or real numbers, etc., in order to talk about what we see on the graph. So let's get started. So a friendly reminder that the last lesson that we learned, we talked about all numbers exist in a classified set. And the classified set here is the real number set. When we talk about functions like graphs and we talk about equations and we talk about quadratics, linear equations, cubic equations, any kind, we talk about those graphs being having a domain that exists as part of the real number system. So it is important to remember that all numbers exist in the real number system, or you could talk about irrationals, rationals, integers, whole numbers, counting numbers. But for now, we need to definitely remember that all of the numbers exist as real numbers. So the definition of domain and range. In its simplest form, the domain is all of the possible values that could go into the function. So we're talking about the inputs. And the range is all the possible values that could come out. We're talking about all the outputs. So when I talk about like the domain, I really am talking about the set of all possible values of x that work in a given function. So when I say work, I mean that I could evaluate the function there and I wouldn't get an error on my calculator. When I talk about the range, I talk about all the possible values of y that I could get out of the function. So this would be anywhere that I can put in an x, I should get out a y. So if I can put x's in all over the function, the range should also be the same. Like I should get all of the possible values for y that exist. So let's take a more detailed look at domain and range. And the first thing we need to ask ourselves is, does every function have a domain? And the answer to that is yes. But in the previous math classes you've gone through, you probably never even noticed this. So like you've definitely graphed linear equations before. You've probably graphed a quadratic or two, but you never really talked about what its domain was. This was because we always assumed what the domain was. We kind of subconsciously did it. We didn't even really know we were doing it, but you kind of knew that the domain was assumed to be all real numbers from negative infinity to infinity. And how did you know that? How did we assume that? You're probably thinking to yourself, Mr. Wertz, I never did that. I never assumed. I never even knew what you were talking about. It turns out that when you were drawing a graph like this, for example, arrows on the end of the graph pointing towards the left and pointing towards the right are actually a way for us to show on a graph that a graph goes for forever. And since the graph goes for forever, it would mean that its domain is all real numbers. So any possible number, irrational, whole number, decimal, counting numbers, integers, anything, they're a part of the domain. The function would work there. So if we were only studying whole numbers, though, like if we had a specific limit on our domain, we would assume that that domain is only whole numbers or etc. When it comes to the more advanced work that we're going to be doing, we need to actually be more careful. So this is why we're talking about the formal definition of domain and range. So if I visualize it on a graph, I can see that the domain is the stretch horizontally of all of the numbers that the function could cover, and the range is all the numbers that the function covers vertically. So between this point up here and this point up here is the range, and between that point here all the way over to here, or this point up here, excuse me, is the domain. So that kind of should give you an idea of what we're talking about when it comes to domain and range of a function, but I still have a couple more points that I'd like to go through. Especially, I would like to talk about things that cause the domain to change. So Usually, okay, we're operating under the assumption that the domain of a function is all real numbers. However, if the graph does not end with arrows, meaning it does not go on for forever, it's going to be limited. So we're going to have a smaller domain than all real numbers. If the function has a variable in the denominator, so like it's 2 divided by x, for example, x could be 0 at some point. If it is, that causes a problem because you can't divide anything by 0. So the function would not work there because it would give me an error on my calculator. So that would create an excluded point. If the function has an even root in it, like a square root, a fourth root, a sixth root, so when you're taking the roots of numbers, it would cause it to have a limited domain of only positive numbers because you can't take the even root of a negative number. Like, try it. Try taking the square root of -4 in your calculator. You can't. It's going to tell you error. So when you do the square root of something, it's essentially telling you, you don't have any negative numbers in the domain. And the graph has a closed dot, an included point, which should middle. All of those excluded points, those open dots, are not in the domain, so they would cause it to be different. So the next thing I want to talk about for range is minimum versus maximum. A graph's maximum is the highest point of the graph, whereas a minimum is the lowest point of the graph. And that seems very trivial. It seems pretty obvious, but it means that the bounds, okay, the ends of it, the range, are from the minimum to the maximum. So you would have the minimum listed, and then you would have the maximum listed, almost looking like a coordinate. If you cannot see a minimum or maximum, or the graph has arrows on it that point up or down, the graph would then be assumed to go on forever in that direction. So if the arrows point up, the graph goes on forever that direction. If the graphs go down, then it would go on forever in that direction as well. So let's go ahead and proceed to the next part I have, which is how are we going to determine the domain in the range? The best way to determine the domain and range of a function is to graph it. Make sure that you fit the window of your calculator properly to find the function to see if it has any holes in it. Look to see if it ends at any point. Look to see if there's anything missing, etc., etc. Then you need to check and ask yourself, what is all of the horizontal distance that the graph covers? So that is the domain. And then try to figure out what is all of the vertical distance the graph covers. That is the range. Then, once you know those things, you just got to write it out. You just have to tell your reader, you have to tell the person, this is the domain and this is the range. So here's an example of that. I am going to graph the function f of x is equal to 2 divided by x. So I go into my calculator, okay, and I type 2 divided by x into the y equals editor, and I graph it. And I get a graph that looks like this. So you guys are going to have to just be patient because this is not going to look the best, but it's just for show. Okay, so I get a graph that looks like this, and then it comes from up here and comes down like this. So now I'm going to actually take this and edit it a little bit. There we go, and slide this way. So my graph looks like this. It very clearly looks like my graph is trying to avoid the middle of the graph. So the domain would be assumed, so actually hang on, I do need to note that there are arrows here. The domain would be assumed to be all real numbers, and I'm going to change the size of my text here, 18. The domain would be assumed to be all real numbers, except I have to look at the graph and I have to see where can I not actually put this into my calculator. So I would go and I would look at my table. Okay, so I'd use my table feature, and I would kind of scroll through some of it until I see that error. So I see that there's an error at 0, except x cannot equal 0. So essentially what I am saying is every number is okay except x cannot be 0. So when it comes to mathematically how to write this, we don't even need to write the word except. We can just say all real numbers, comma, so that kind of tells us, however, x cannot be 0. And if you put a 0 into the function here, all right, if you tried to actually do this, so we're going to confirm it, pen, if you put a 0 in here, we would get f of 0 equals 2 divided by 0. And then you would try to push that into your calculator, and you'd be like 2 divided by 0, and you'd be like, oh no, error, divide by 0 error. So you would get that this is not part of the domain. So it's not in the domain. So the domain is all real numbers, but x cannot be 0. So continuing. What is the domain and range of the following function? So we're going to graph it. Just like we're going to do with everything, is if we don't have a graph if we don't actually see the graph immediately, we're going to graph it ourselves. So I'd go into my calculator and I'd type 3x minus 4 into the y equals equation editor, and I would hit graph. And when I do that, going back really quick, I would see that my equation goes up like this. So I'm gonna cheat a little bit to make a nice straight line here, and that is what the graph of it looks like. Now, on my calculator, my graphing calculator, I literally took exactly what was on my graphing calculator screen. You can see it right here, and put it on that graph. However, what the graphing calculator does not do a good job of actually showing you is that on the ends of the line here, there would be arrows. And how do I know there would be arrows? Is because if I go into my table feature, that graph, I can continually scroll up and down for forever. And if I were to trace that graph, I could trace it for forever. There would be no end to that equation. So the domain of a function like this, because it has arrows pointing in both directions. So the arrows on the top and the bottom actually point two ways. They point both right and up. So the one over here, this one points right and it points up. And this arrow points left and it points down. Because the arrows point left and right, the domain would be all real numbers. And because the arrows point up and they point down, it would also be all real numbers. And the other way to say this, okay, mathematically, would be from negative infinity to positive infinity. And the same thing here. It would be negative infinity to positive infinity. And so the symbol, I just wanted to type the words, but the symbols would be, negative infinity to positive infinity. And the same thing here, negative infinity to positive infinity. All right, moving on. So if I have a more limited function here, okay, so I have a small portion of the graph, like it's very limited, determine the domain and range of the function below. To determine the domain, I'm going to want to go from here, this point on the end, and I want to go all the way over to here. So this is the horizontal distance covered by the function from -5 all the way to +4. But I have to be careful, okay? And so I do need you to make sure that you remember this, okay? So I'm going to put it down in the here with some text. If the dot is open, you use a parentheses to indicate that point is excluded. if the dot is closed, you use a bracket to indicate that point is included. So the reason that I used a parentheses with infinity is because infinity is not a point that I can actually go to. It's an idea. We can't put a point on infinity. So because we can't put a point on infinity, we have to say it's quote unquote excluded. That is why I use a parentheses for that. So for the domain here, I'm going to use a parentheses for the -5 because this is open, and I'm going to use a bracket for the 4 because this point here is closed. Now for the range, I'm going to use a different color for the range. So I'm going to go pen and I'm going to go purple. The lowest point is again here, and the highest point goes all the way up to here. The lowest point has a height of -2, and the highest point, the maximum, has a height of 3 on the y-axis. And so the -2 again is the open dot, so I need to use a parentheses, and the 3 is a closed dot, so I use a bracket. So that is the domain and the range of this limited function. And so here is a problem that I found on an ACT related to domain and range. So let's parse this. Let function f of x equal x squared minus 3 be defined for -2 is less than x is less than 4. The range of f of x is what? Okay, so this looks way more complicated than it is. Essentially, they're telling you this is the domain. They're saying that the domain is from -2 to +4. And they're saying it as if it is not included. If it were included, they would use the or equals to part. But they don't. So instead, we're going to say that the domain is from -2 to +4. To calculate the range, we're going to substitute those 2 points in to our function and record what we get from those points. So what we are going to do is type in x squared minus 3 into our calculator. And I'm also going to, and I'm going to graph it just to get an idea of what that function looks like. And now, if I were to actually substitute a -2, a -2 would give me 1, and 4 would give me 13. But if I look at the table of the graph, like I'm doing right here, I actually see that 1 is not the lowest point on the graph. The lowest point on the graph is actually -3. And the highest point on the graph, the highest y value between -4 and 2 is 13. So the range would be letter D, from -3 to 13. So again, if I'm going to sketch the graph for you too so you can see it. It goes like this, comes down, it's -3 and goes back up. What they are doing is they're putting an artificial limit on it, and they're saying only from -2, which is here, to 4, which it would be over here. That's the only area you should consider. So the highest point is up here at 13. It would be 4, 13. And the lowest point is down here, which is 0, -3. And so the -3 to the 13 gives us our range. And that's it, guys, for today's lesson. So in summary, that domain is the set of all numbers that we can use in a function's input. Range is the set of all numbers that we can get out of a function's output. So we got the x's for input, the y's for output. We can find the domain of a function by graphing it and looking for any missing points. And the range is the collection of points from the minimum to the maximum on the graph. So it's always a good idea to graph a function to find its domain and range. So that's it for today's video, guys. Thanks for watching, and I'll see you in the next one.